Okay, this is the homework help video for Unit 4, Worksheet 6, Honors Math 3, and this is question number 9. So the first thing I'm going to do is I want to factor. So I'm going to go ahead and factor in the numerator so I can take an x out of both of those. And so that will leave me with x plus 2 on top. And then in the denominator, I'm going to factor, trying to find numbers that multiply to negative 18 and add to negative 7. And so that would be 9 and 2, so 9 and 2. And then negative on the 9, positive on the 2. Okay. And so then this is going to cancel, right? And when that cancel, then that means I'm going to have a whole at x equals negative 2, because that's the factor that cancels. So then my new function that I'm working with is I have an x in the numerator and then x minus 9 in the denominator. Okay. So I want to go ahead and find my vertical asymptote first. So I'm looking for the vertical asymptote. And so for the vertical asymptote, remember we look at the denominator of the reduced fraction. So here's my reduced fraction. And so my denominator is x minus 9. And I want to set that equal to 0. And then just solve that equation. So then I'm going to add 9 to the other side. And when I add 9, I'm going to get x equals positive 9. So then I have a vertical asymptote at x equals 9. Okay. And then for my horizontal asymptote, I want to find the limit to infinity of my reduced fraction. So here's my reduced fraction. So I'm going to take the limit of my new function and then let x approach infinity. And so then I'm going to do the shortcut way. So I'm going to compare the degree. So these are both degree on 1. So I'm going to look at the coefficient of both. So that would be 1 over 1. So my limit would be 1. And so then I have a horizontal asymptote at y equals positive 1, right? Because the limit always finds me a y value. So I have a horizontal asymptote at y equals 1. And so then now I'm going to look for my hole. So I'm going to do my hole over here. So for my hole, I know my x value was negative 2, so negative 2. And so in order to find my y value, I want to substitute it into the reduced function. So I'm going to just do that work below it. So I'm going to replace x with negative 2. So that would be negative 2. And then negative 2 minus 9. And so then my hole would be at negative 2 over negative 11, or 2/11. So when I graph it, I'm going to graph at negative 2 and then 2/11, or just a little bit above 0. So then now I want to find my x-intercepts and my y-intercepts. So for my x-intercepts, I'm going to let y equals 0. And so now I really only have to look at the numerator, right? So I really only have to look at the numerator. So then if I look at just the numerator only, then I know that x is equal to 0. So then there is my x-intercept. And then finally, I want to find my y-intercept. So to find my y-intercept, I would let x equal 0. So I'm going up here again to my reduced function. And then I'm going to replace x with 0. So I get 0 over negative 9, which is 0. And I should have expected that, right? Because if my x-intercept is 0, then that means my y-intercept has to be 0 as well, right? Because that would be the origin, and so the only other place it would cross would be at y equals 0. Okay, and so then I'm going to set up a little bit of a graph here.
What do you have? Oh.
And so, so I have a vertical asymptote at x equals 9.
Well, the only person I can go across the hall there we can ask them, or Mr. Morgan.
And then I'm going to count by 2s on this because I know I'm going to need a little bit of space for that. So at x equals 9, I have a vertical asymptote. And then I have a horizontal asymptote at y equals 1. So again, I'm going to count by 2's here. So at y equals 1. And then I have an x and y intercept at the origin. And then a hole at -2. And then 211, so barely above. Okay, and that's it.